Today I will be going over how to solve a trig substitution example when we're given the values associated with the integral of a sine theta. Alright, so the question starts off with what is the indefinite integral of the square root of 9 minus x squared divided by x squared dx. So with trig substitution, when you're given a problem at first, you need to figure out which formula you're going to be using, right? So there's three formulas in trig substitution. A squared minus x squared equals a sine theta. Indefinite integral of the square root of a squared plus x squared equals a tangent theta, and the indefinite integral of the square root of x squared minus a squared equals a secant theta. So if we go back to our problem, we can see that we have a 9, which is a positive integer, and we have a negative x squared. Which formula would be associated with that? There's only one negative x squared that I see, and that's this formula. So since we have a negative x squared and we have a positive a value, that means we're going to use the formula a sine theta. Yeah. So let's go to the next step. The next step is you want to get all your values associated with it. So if you look at our formula, we're going to need to get a dx. So we're going to have to take the derivative of x, and we're going to need an x squared. But first, we need to change everything into the formula. So x is going to be equal to a sine theta, remember? And because that's the formula says, right? Everywhere we see x, we have to put a sine theta. All right, so x is going to equal to a sine theta. That means a squared is 9. We take the square root, a is equal to 3. Remember, x is equal to 3 sine theta. We just figured this out through this. And since we have x squared in the problem, we're going to square x. So that will make x squared equal to 9 sine squared theta. And remember, we need a dx as well. So if we take the derivative of x, we will get 3 cosine theta d theta. All right, so now let's plug our information in. If we plug information in, we'll get 9 minus x squared, and like we said, x squared was this, so we plug in this value. X squared over here is this value, same thing, and our dx, see, we said was 3 cosine theta d theta. So as you can see, I simplified it a bit. Since I see we have a 9 on the bottom and a 3 over here, we can cancel these out, and we can make this 1/3. Right? So let's rewrite the problem. Now we have the square root of 9 minus 9 sine squared theta divided by 3 sine squared theta times cosine theta d theta. All right, so what can we do? Can we simplify this further? Yes, we can. How are we going to do this? We are going to basically take out a 1 from the square root sign, and we're going to take the 9 out, and if we take the 9 out, we're going to be left with 1 minus sine squared theta. Do you see how we did that? If I were to distribute the 9 again, it would be equal to the same thing. We're able to do this because we don't really change the value. It still equals the same thing. All right, now that I took out the square root of 9, what else can I do? What I can do is I can change the identity. How would I change the identity? This is where you need to know your trig identities. All right, so remember that remember pre-calculus sine squared theta plus cosine squared theta is equal to 1. Well, if we rearrange it, it shows that cosine squared theta can equal 1 minus sine squared theta. So what do we have over here? 1 minus sine squared theta. So now we're just going to replace it. Boom. Now we replaced it. What can we do now? There should be the other portion right here, cosine theta d theta. It just got cut off. It's there. So what we're gonna do now? We're gonna use the square root on the numerator. if we use the square root in the numerator, we get that we have 3 cosine theta divided by 3 sine squared theta. Now what are we going to do? I'm going to try to simplify this. 3's cancel out, and now we're left with cosine theta divided by sine squared theta times cosine theta d theta. We have to simplify even further. So what I'm going to do is I'm going to multiply cosine squared theta out, and I'm going to be left with cosine theta divided by sine squared theta. Now I want to put one variable if possible. So what I'm going to try to make it easier for me is I'm going to change cosine squared theta back to what it was previously before, which was 1 minus sine squared theta. Now I'm at 1 minus sine squared theta. I can break this down even further into 2 separate fractions and get 1 divided by sine squared theta minus sine squared theta divided by sine squared theta. 1 minus sine squared theta is going to be basically cosecant squared theta, and sine squared theta divided by sine squared theta is basically 1. So now we have this. What we're basically going to do is take the integral, and you should know from Cal 1, the integral of cosine squared theta is going to be negative cotangent theta, and the integral of negative 1 is going to be just theta. Right, so this is our answer, but unfortunately, if we start off with an x, we have to end with x. So right now, we just have to take the finishing steps and change theta to x. So how are we going to do that? All right, so remember that x is equal to 3 sine theta, right? If we divide 3 on both sides, we get sine theta is equal to x over 3. That's basically a right triangle. So what I want you to do is draw a right triangle and input the values. So sine theta, the definition of sine is basically the opposite of our hypotenuse. So we know that the x is going to be the opposite side, and the 3 is going to be the hypotenuse. So how are we going to find the adjacent side? Pythagorean theorem, x squared plus b squared equals 3 squared. Rearrange for b, and we can say that 9 minus x squared is the adjacent side. Now we go back to our original problem. So we found out that negative cotangent theta minus theta is plus c is our final answer. How are we going to change this? We input our values, right? So theta is going to be inverse sine x over 3. Why? Because if we want to isolate theta, we would have to just take the inverse sine on both sides, and that would give us theta. That's how we solve for theta. But for negative cotangent, I just factor the negative out. It's not important. The definition of cotangent is adjacent over opposite. So if we look at our triangle, our adjacent side is over here, 9 minus x squared, and our opposite side is x. So we just input our variables for that, our values for that. And boom, there's our answer. So the indefinite integral of the square root of 9 minus x squared divided by x squared dx is equal to negative square root of 9 minus x squared divided by x minus the inverse sine of x over 3 plus c. And that's how you would solve an example of a sine